Hey, good evening, everyone. Welcome to session 4 of our Essential Christian Apologetics class. We're moving on through. Let's pray, and then we'll talk about where we're headed for tonight and then going forward. So, Father, we thank you once again for all you do in our lives, Lord God. We thank you for your creation. We thank you for your blessings and mercy and grace. We thank you for your salvation. We thank you for the opportunity, Lord God, to learn and explore truth, Lord. Help us to have minds that are able to fully perceive what you would reveal to us, Lord God. And help us, Lord, to just engage in this discussion with those who may struggle to understand the box top of life, as our authors like to use the term. So help us to have eyes to see, ears to hear, hearts to perceive, and lips and mouths to speak, Lord God, the truth of your word, the truth of your creation, wherever we go. And we just want to be prepared for it. That's why we're here. We ask, Lord, for you to equip us and guide us and lead us in all things. And we invite you here tonight in Jesus' name. Amen. All right, so we're in session 4, and the last couple of weeks have been fairly science-y. This will be our last foray into kind of science topics for the most part. We've been going through lines of evidence, if you will, and so as the authors tried to do in our primary book, I don't have enough faith to be an atheist book, is to start from a very, very beginning point and just talk about, well, how can you ever know anything is real at all? How can you know what truth is? And we began to see that those claims that you can't know truth, end up falling apart on their own claims. They try to make claims like you can't know truth and all these things, and we start realizing, no, wait a minute, even making a claim like that is an appeal to truth, and therefore you do believe in some level of truth. So we believe in truth. And the next line of evidence is really looking at some of the best philosophical understandings or attempts to explain the universe or the world or whatever it is they would claim it to be that we live in, and do they actually hold any water? And the answer is typically no, they don't. There's not, in these philosophical systems, there's this discussion about, can you really know anything? And, again, using Immanuel Kant, is the tree outside the window really a tree, or you just imagine it in your own mind? How can you know? And we, hang on a second. Oh, all right. Sorry, I got to go back. I thought I moved that over. What the heck? That was really weird. Well, oh, I got to get the logo off. Oh my heavens. Help if I knew that program better. All right, so now that's fixed. Sorry about that. All right, so we looked at the lines of evidence and philosophical claims. Can you know truth? And they don't seem to really explain existence all that well. We could look at Rene Descartes, going through his whole mental process, and I think, therefore I am. I must exist because non-things don't think. Right? That was his whole line of argument. We didn't see that in this book, but that's kind of that thought process is, hey, if I'm a thinking rational, I can decide this must be true, or I'm actually thinking about thinking, then I must exist. So that's kind of Rene Descartes. And then we've looked at these other lines of evidence to say, what does the evidence that we see around us, observable, even testable, and fitting within a logical framework, what does the evidence suggest to us about the universe we live in? And so we see the fact that the universe clearly, even by any kind of secular, atheistic, scientific claims, had a beginning. And so if a universe has a beginning, then something began it. And we haven't begun to truly answer the question of who or what that is. We just simply said a very valid line of evidence is the universe we live in has a beginning, and things don't pop into existence out of nothing. Certainly not something as complex and as well-designed and fine-tuned as we have. It certainly can't pop into existence out of nothing. We have no experience with that. So the most rational conclusion is something incredibly powerful and incredibly intelligent to create what we see has caused the existence that we live in. So we call that the cosmological argument. You can look up lots of information on the cosmological argument online or in various resources. I certainly encourage you for any of these lines of resources, answersingenesis.org or .com, I can't remember if it's both, and Institute for Creation Research. Having practically any question you've ever asked about how can I know this, or what's the scientific rationale on this particular point, they probably have dealt with it with their own in-house staff of PhD scientists and whatnot that they've looked at these things. So anyway, cosmological argument. Then we looked at the teleological argument, meaning looking at the end result of things. So the cosmological says, well, we see a beginning, and beginnings require something that began it, so that's one line of argument. The other one is when we look at the incredibly fine-tuned design of the universe and every aspect of it, it sure screams intentionality, it screams purpose, it screams a design that requires a designer, like a watch, Paley's watchmaker argument. A well-crafted watch requires a watchmaker. A well-crafted living organism requires a living organism creator, right, of some sort or another. And if any of you, I don't know if any of you watched the videos, I threw some up here on the screen before you got here. Can't really show them when we're doing live stream and things like that, just from copyright stuff and all that. But I gave you some links if you wanted to look at them. But what you see in the complexity of the DNA molecule and the construction, converting it from DNA to RNA so that it can make a transcription of itself, and going through this incredibly fast process of copying more information than 1,000 encyclopedias in just a few seconds, basically, is incredibly fast and incredibly efficient and incredibly well designed. And that's just one small aspect of the cell. There's all kinds of other functions that happen within the cell. As we talked about before, there's there's like a post office, and there's a delivery system, and there's a waste management system, and there's energy management system, and there's obviously the self-replication of mitosis or meiosis within cells, and all these things that happen within cells. Incredibly complex. So we look at the end result of anything, and we see it doesn't look like an accident. Every accident I've ever seen causes destruction. Explosions rarely put together buildings, and tornadoes rarely put together airplanes, and accidentally dropping a box of Scrabble tiles on the floor rarely spells out a meaningful sentence, much less something so significant as to build a living system, right? But that's what we look at with the teleological argument. And then, so we've looked at these kind of components of things. We're going to look next week at the next phase of that, which is the moral argument, okay? And we've kind of alluded to that on a few occasions, that where does everybody get this sense of right and wrong from? And it always seems to be conforming to a unique and independent standard from people's opinions. People have different opinions about what the standards might look like, but they really don't differ very much on the fact that we have them and should obey them. We'll look at that next week. Today is just kind of a walk through the last part of the science and creation versus evolution type debates. This is just a very small thumbnail sketch of that. Again, there's a few weeks ago I had DVDs and videos and books and stuff up here. If you want to watch or read on that topic, there's just mountains and mountains of incredibly good information about that from a variety of resources. I can direct you in the right direction if you want more specifics on a specific topic or a general overview. So this one, the chapter 6 in our textbook, is called "From the Goo to You via the Zoo," right? And so, is that really the most descriptive box top of life? Is that how we actually got here? Did we start off in a non-living things, and then suddenly a single, very highly complex, single-celled organism popped into existence? And then did it have the capacity then to go into a multicellular organism, and then from multicellular organism into multifunctional systems with digestive systems and respiratory systems and circulatory systems and all of those other systems? Did it have the power to make that jump and that leap from a single cell floating around in a liquidy surface or a substance into, let's say, the pinnacle of things, mankind? Did it have the ability to get from A to Z to that point? We'll look at that kind of information tonight. So our question is, does the box top of life seem to indicate we came through the zoo. If you take a walk through the zoo and you look through at the orangutans and the gorillas and the lions and the reptiles and the fish, is that our pathway to our own existence? Or did we actually come about, as maybe Scripture has to say, we haven't gotten that far yet, that God formed us of the mankind of the dust of the ground and breathed the breath of life into our nostrils, and suddenly man became a living being, which seems to be more descriptive or accurate against the facts and the evidence that we have. So, again, this is a little bit of covering ground we had last week, but let's continue through it. So, again, this is chapter 6 as your notes, and I put page references in there where it seemed appropriate to kind of direct you to these points. But repeated observations, the authors make a claim, tells us that the only intelligent beings create messages, right? And we looked at that a little bit last week in chapter 5, I think it was, where it says, take out the trash, Mom. And is that an accident? Should just ignore that. That has no meaningful purpose. It's just a scramble of letters that I could say tells me to do some chore that was on my list of chores to do. Or is it just accident? It just happened to fall into that circumstance. Well, we recognize that even the simplest of messages require an intelligent source for that information to have meaning and to have purpose, like we might see in a simple communication of a note from a mother to a son, or and certainly in the level of complexity we see like in our DNA molecules that build our entire living systems. So even Carl Sagan, anybody not know Carl Sagan? The name, the Cosmos series that he started, certainly got me started on my road to atheism long ago. Watched the whole thing and just thought, well, sure, that makes lots of sense. Okay? Even Carl Sagan, very outward, forward, atheistic, materialistic human, realized that human brains, right, he would make the same claim, contain enough information, so our brains, average human brain, to fill 20 million books. So if intelligent beings cannot create anything close to the human brain, why should we expect non-intelligent natural forces and laws, or whatever these things are, accidents, to create the kind of information that's contained in the gray matter that happens in our brain? There's incredible amounts of intelligence in every human being. In fact, there's so much processing power going on in any given moment. Your brain, or my brain, all of our brains are processing colors and motions and sounds, and our systems are breathing in, and we're blinking to make sure our eyes stay wet and moist, and all these things are happening, and our brains, the functions that aren't automatic, if you will, are happening. Our brains are calculating all these things. The calculations to walk a straight line for a bipedal type person is incredible. How much force to put forward, how much force to leave off, the stride, the balance, all of those things. Your ears are connected to your balance, and your eyes are connected to your balance. You may not know it if you haven't watched that video I told you, I think a couple of weeks ago, the seeing eye and the hearing ear, or the hearing ear and seeing eye, whichever one it was. He talks about that. Dr. Minton talks about that. Just walking down a line, your eyeballs do an ever so slight shift because you're off balance with every step. And so your eyeballs are shifting every single step, and you can't tell it. You're walking, you can't see that your one eye is dropping a little lower than the other to keep your sight level while you're going unlevel while you're walking across the room. Okay, all of those kind of calculations are happening within your eyeballs. So, and in your brain. So if our brains are that complicated, how, with 20 million books worth of information, where did that information come from? What is the most natural source we could appeal to in terms of why we have it? So we go all the way back and say, well, what about new life forms? So Darwinists, materialists, atheists, whatever nomenclature you want to put on that, still need to explain both the first cause of everything, like the Big Bang. That's the first cause of everything in our existence. And then they also have to explain the origin of the first life, biogenesis or abiogenesis, life from non-life, before they are able to take even the next step to advance the discussion to more newer and more complex life forms. They can't explain the Big Bang. They can't explain where nothing created something. And they can't explain, we've looked at, like with Sir Fred Hoyle and that whole 747 in a junkyard analogy and a 10 to 40,000th power worth of probabilities to get to the first components of life. And he said it's impossible. They can't get past that, but they still want to claim the next steps are that we really did, even though we don't have any explanation for how nothing created something, and something incredibly complex and incredibly fine-tuned, and we can't explain how chemicals and reactions and things like that went from non-life to suddenly life appeared. Can't explain that. Simply, we can't recreate it in a lab. We can't explain it on a whiteboard. We can't do any kind of explanations on those things. But then they want us to walk through the zoo and say, okay, ancestor, 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 ancestor. Oh, here I am, right? They want us to believe that. But we need to understand some major differences between two very different things that are usually conflated into one. Microevolution, you call that change within a species or a kind, a family matter, whatever it may be, and macroevolution, from species to species, or from family unit to family unit, or biblically from kind to kind. Is there any evidence that supports going from one kind to another? I'll use the term kind. It's most familiar to me because that's what God said in Genesis chapter 1. They will multiply according to their own kind. So, evolution by blind, non-intelligent forces, that's not a pejorative, that's what they claim, okay? That there's no intelligent forces behind evolution, it's just nature, is merely a hypothesis, okay? As such, blind forces don't make selections for anything. They have no preferences. So until it has function, the eye is one of the most common ones that we'll talk about, right? The eye, until it actually provides function, it provides no benefit to the organism. So if you're thinking about a fish, or you're thinking about a reptile or a salamander or something, and you say, well, its survivability jumps from here to here when it has the ability to see to escape predators or to see to catch its own prey, well, you have to have that functionality has to come into existence and be useful, because natural selection will not say, you know, that's a really good advancement. You can't see anything yet, but I see where you're going with that. Let's keep that thing around. Eventually it'll come to a benefit to you. No, it has to be fully functional, or it aids in no capacity, no form, the survival of that species. Okay? So it has to have, because natural selection needs to have a preference, but until the preference is actually a survival benefit, there is no preference selected. Okay? So survival of the fittest is what you hear a lot. You probably have ever been in biology class or any other kind of science class, or you look at this kind of information. They'll say the mechanism for life on the planet and all the variations and diversity that we see from the goo to us in the zoo, through the zoo, is survival of the fittest. Okay, they survive because there's this struggle and there's this battle, and the fittest survive. Well, we don't disagree with the fact that things that are stronger survive better than things that are weaker, right? A lion that is the king of its own jungle is far more able to survive if it kicks all of its competitors out, because it's the strongest lion around. And the younger ones, the weaker ones, can't compete against the strong lion. They can't find their own food source, and we can see they die off. No one disputes that animals that have a stronger survivable skill set don't survive longer. That's not the point. What we would refer to this in the logical scheme of things is called a tautology, okay? A circular argument that doesn't prove what it claims to prove, okay? So they want to claim that because the king of the jungle lion is better equipped to survive, somehow that means that that's how he got to become a lion, right? That he became a lion because of survival of the fittest. Well, a tautology is really saying the same thing twice without adding anything new to the meaning of something, right? So what they're doing is making a claim that survival of the fittest explains how our existence, or the arrival of the existence of life, but it's really just saying that things that are equipped to survive better than things that aren't equipped to survive. Okay? If you're not following this, let me try to help you with some more simplified examples. Okay? An evening sunset. Do you gain any new information by those two words? Does the sun ever set any time other than the evening? Right? So you're not getting any, you can talk about the sunset, but adding evening to it doesn't tell you anything you didn't already know. The sun was setting, it was evening. Okay? How about frozen ice? Okay? We want to be really, exaggerating. That ice was really frozen today. Well, is ice ever not frozen? I mean, water can exist in lots of forms, but if it's ice, it's frozen, right? You don't add any new information by saying, I want some frozen ice today. I heard it with my own ears, as opposed to hearing something from somebody else's ears. Right? These are tautologies. These are using the same word to make it sound like it means something meaningful is being said, when in the end you're all just saying the same thing. Okay? An over-exaggeration. Well, is there an exaggeration that isn't overstating something? Exaggeration is exaggeration. It's overstating something. So over-exaggeration is not very helpful in terms of language precision. How about close proximity? Can something be close without being in proximity? We use these terms all the time. I mean, most of these are not necessarily foreign to our ears, right? I'm going to be in close proximity to, the computer screen. Can you be in proximity to something without being close to it? Doesn't make any sense. The same thing, the same concept is true when you say survival of the fittest is the mechanism by which we brought about all the existence of species on the planet. No. We have species on the planet because they are able to survive in their environments. It doesn't say that that's how they became the species themselves. Okay? It's just it's a tautology, but it's also a diversion from the facts. The fact that there are no details that explain the arrival of a new species. So we need to kind of define evolution, and defining evolution is the single greatest point of confusion in the creation evolutionary controversy, right? So what do you mean by evolution? When I say evolution, does that mean or somebody says you don't believe in evolution, does that mean I don't believe in evolution? Really? That animals can't, in a sense, evolve? That's not what I'm saying. Or that's not what most creationists or biblical kind people would look at. They would say, no, I believe in evolution, but evolution has its limits, and its limits are defined by, in most cases, the digital code of the DNA. Okay? Evolution within a kind. We'll talk about some of that here in a moment. Like, in fact, this one is pretty well known. Antibiotic-resistant bacteria. You probably have heard somebody make some kind of claim about, well, antibiotic-resistant bacteria might prove evolution or has proven evolution. Okay? Let's talk about that for a moment. Okay? Surviving bacteria always remain bacteria. So what we find is we put antibiotics in something, and for a while it works, and the bacteria are killed off by the antibiotic. Then over time, and you probably all hear this, we can't give that antibiotic to you over long, because if we do, the bacteria could develop antibodies or a different mechanism to fight that off, and suddenly this drug, this antibody, won't fight against the bacteria. Okay? But what we find is, in that even in those cases where there's been some changes, and we would call that change evolution, they're still bacteria. They haven't become a different species. In fact, they haven't added new information. What they've done, and scientists can easily confirm this, is they've stripped themselves down of unnecessary information in order to survive. So they've survived in species, but as a species, they are less equipped to fight off other issues down the road. Let me try to pull this in together. So it's like if you're on a ship, okay, and we can read this in like Acts chapter 28, isn't it, or 27, 28, whatever one, where Paul and the sailors are in the ship, and they're realizing they're going to run aground, and they need to make way. And so in an emergency, what do? They start throwing off the cargo. There's this cargo ship, and we're running low. We need more mobility. We're overloaded, and they start throwing off stuff off the ship, okay, for the hope of surviving a shipwreck or avoiding a shipwreck. That's what bacteria are doing, is they're saying, this antibody is coming in and it's attacking this system within the wholeness of my bacteria, okay? And somehow it's been able to respond to its environment and say, well, if I throw that away, I can survive when that antibody comes back in and tries to kill me. Okay? But it never gets it again. And so it throws away some parts of its DNA, and then it becomes a less equipped bacteria, and it becomes less able to multiply and survive down the road. Okay? So it's not gaining this new ability. Ha, I'm so strong I can fight off these antibodies. It's taking emergency action and saying, if I don't cast off the things that this antibody is trying to kill me with, I'll die. And somehow, some way, it's been programmed to cast those things off, but then it's 80% of what it used to be. It's 70% of what it used to be. And if it goes off and multiplies and divides, it will very easily die in a different environment where that antibiotic isn't even present. Okay. Hopefully that makes sense. I'm not, there's books and, descriptions on how that could work, but that what we see is not a gain of new information. We see a loss, intentional loss of information for a short-term survival, not a long-term viability plan for the species itself. Yep. Right. Yeah, because you're dealing with, we're dealing with a fallen world, right? And so we have these things that are attacking our bodies, and we have medicine that's designed very specifically and very targeted to kill something that is causing us pain, causing us disease. And so it comes in and it does that. But, and I would make the appeal, the book hasn't gotten that far yet, but I would make the appeal that God put in every living thing a survival mechanism with which it can fend off attacks from outside, okay? And so it's fending off this attack that the medical professionals have injected or whatever into us, into you, and it's adapting to that, and over a period of time, it's adapted to the antibiotic, but adaptation means a loss of abilities, a loss of function, not a gain into new superpower, okay? Like if you get in a car accident, or you step on a landmine or whatever, or a hand grenade, and your leg is partially blown off, and they say the only way to survive the person is to cut off your leg. Okay, we cut off the leg, and now I've survived that gangrene or whatever is trying to attack me. But no one would be claiming that me walking around with one leg versus two, I'm a better person for it, right? I've attacked what was attacking me, and I've cut something off, but I've gained no new functions. I've lost abilities, I've lost functions, but I have a short-term survival that I didn't have without that remedy. Did you have something, Kirk? Mm-hmm. Oh, yeah. Yeah. And we all knew it was coming, right? Right. But you see it coming. We've developed a vaccine for the COVID virus. I think we all knew that the virus would adapt and change, and suddenly the original vaccine wouldn't have the effect, even if it ever did, have the effect that it was supposed to have in terms of, we're going to eradicate this COVID thing. Well, no, it just keeps mutating. But in the mutations, you're not seeing a different virus. You're not seeing something new. You're seeing it finding ways in its survivability to cast off things that would destroy it, so it can survive and keep going a little bit further. But it's not gaining new genetic information. Okay. Yeah, overall it's weakened, and so now it's like you said, it's like a bad cold. Okay. So natural selection has never been observed to create new types. We find no evidence in the fossil record. We certainly find no evidence in the zoo. We find no evidence anywhere at any time have we ever seen these supposed transitional forms or anything new that popped into existence. We just don't find it. We've been searching, or secular scientists and all that from even before Darwin have been searching and searching and searching, and in the lab trying to force new mechanisms, and they can only do limited amounts of manipulation. We're not ever seeing, there's been no observation of any new types. In fact, there's this meme out there floating around. I probably should have thrown it in here. Richard Dawkins, a well-known atheist and Christian or Bible hater, said, we know that Darwinian evolution has been, and natural selection or change over time has been observed. We just have never observed it ourselves. Like, wait a minute. You've never observed it, but it's been observed. It's happened. He's like, we know it's, and it's like, it's the most circular kind of statement or most self-defeating kind of statement you've ever seen. Like, it's happened, and we can prove it, but no one's ever seen it, so we can't prove it. We've never, ever seen, there's nothing in the marketplace where you can say natural selection has ever shown itself to create a new organism, a new type, a new function within an organism that wasn't already programmed in, that may have been dormant and then popped out, but not new functions that were never present in the first place. So the Darwinist claim that small micro changes within a living organism can or should be extrapolated to prove that unobservable macroevolution, not micro, not changes within its own adaptability, but macroevolution, jumping out of a pond and onto the land, and jumping from cold-blooded to warm-blooded, or developing feet, or getting rid of feet, and all of these kind of things. It's never been observed, okay? But they would like to convince the world that small micro changes prove that unobserved macroevolution must have occurred to create the vast numbers of all living systems in both plant and animal kingdoms. But this has no evidence to support it whatsoever. In fact, all the evidence we have actually supports the opposite view, that we have no new species, we have no mechanism by which to get from a amoeba to a fish to a salamander to a frog to a crocodile to a bird to a kangaroo. There's nothing that gets us there, right? We see no evidence of that. In fact, the opposite has always been true, that we see them, let's walk through the logic here. So, by failing to admit, this comes from the book, failing to admit the critical distinction between microevolution, already present capabilities to change within a kind, and macroevolution, is used by Darwinists to dupe the general population into believing that these small, observable changes could be a viable mechanism to explain how all life originated from a single first cell. Now, if you're like me and you watch various things that tried to explain this, you've probably heard of Darwin's finches from the Galapagos Island, and you've probably heard of like the peppered moths, okay? None of these have proved anything that they claim to prove, okay? In fact, the peppered moth thing was really a fraud, by the way. But when we look at dogs, or we look at birds, or we look at any of these species, we say that they clearly have within their DNA the ability, let's say with a finch in beak sizes or beak shape, they have the ability, if food requires a longer, thinner beak, that if that's where the food sources are, those with a fat beak and a short beak will probably die off. And when they die off, they won't reproduce, because that's not what the food source is available for on the island. And so the long beaks survive. And we see, but if the food source changes, and suddenly a short beak is beneficial and a long beak is detrimental to the species, those same exact finches will start to, within their own variability, they will start to see the beak size shrink, not because a different bird landed on plant, or not because this bird populated something that's not a finch anymore, it's because the preferential of the environment allowed for preferential beak sizes to change over time. And we've seen that happen not over thousands of years or millions of years. We see it happen within 1 or 2 generations. Suddenly, the fact that all beak sizes, short and long, fat, wide, whatever they are all inherent in the DNA of every finch. And the environment dictates which one seems to survive in some particular season of time. Okay? And so, we see that variability built into the species, and it's constant there. You can also see it, let's say, with dogs, okay? And let's go with the hypothesis that all dogs started from 2 kinds aboard Noah's Ark, okay? And they had all of the characteristics necessary for the dog kind, which includes wolves and dingoes and actual domestic dogs and various other kinds of animals. I think there's probably 20 of them or something. All of that was built in. But let's just take dogs, okay? And let's say, well, yeah, 2 dogs. Yeah, 1 kind, male, 2 dogs. Yeah, male and his female. Right. Thank you, Les. Yeah. And so from that, we could see easily that if it suddenly starts to get cold, dogs that have a gene for longer hair will end up surviving in colder climates. And if they wore into tropical climates, long-haired dogs would die off, but short-haired dogs would survive, right? And you see that, but you can get from 1 kind, 1 mate, 1 pair of mates, you can see that the variability easily goes out. What you don't have is, as you go off to these all the kinds, and we use this with selective breeding, right? We recognize, okay, all dogs really go back to a common ancestor, but I want a dog with a short nose. Well, I want a dog with a long nose. And so with human intelligence, we preferentially breed long hair, short hair, long nose, short nose, whatever all the different features are, big dog, small dog, whatever it is, we preferentially breed for that. And as we do that, we start to push out to the extremes. But when you push out to the extremes, and those dogs have lost the DNA. Let's say you've got short-haired dogs, and they've got DNA that can only now produce, because you've selectively treated only short-haired dogs. You move them to a cold climate, they no longer have the DNA to get back to long hair, okay? Because we breeded that out of that particular species. So they're going to die, and they're never going to go back to long hair. But if you start with the original pair, they can go in every direction, and they can have all the traits. And this is the same thing with skin tones in humans and all the other stuff. This is all just basic genetics, just like with eye color. Let's use eye color as another one, right? If parents are intentionally going, I want to be like the Aryan race of Hitler, and I want to make sure everybody's blonde hair, blue-eyed. And you start going, okay, I'm only going to marry blonde hair, blue-eyed, and we're going to make sure we have blonde hair, blue-eyed. This was what Hitler was trying to do, right? Is get everybody down to that blonde hair, blue-eyed makeup, and he wanted to purge the population of everything else. If he had succeeded, you would never, ever, ever get back to dark hair, dark eyes of some other variety, because he breeded it out, and there's no longer a dark eye, dark hair genetic makeup in these Aryan races that they came up with. But you can only get down to that by selectively breeding it out. Okay? But obviously, all human beings started with that same adaptability, variability within the genetic code. So when we look at amoebas, we look at dogs, we look at humans, we look at finches. I mentioned the peppered moths. Sorry. The peppered moths, they actually were just pinning them to the trees. They were taking black moths and pinning them to black trees, and white moths and pinning them to white trees. This was always just a fraudulent activity that was trying to prove evolution at the high scale, when it didn't prove anything. It just proved that there's variabilities within moths. That particular moth could go dark or light, and they were then just pinning them to the trees. So it doesn't matter. You have variability within the species. In order for that variability to occur, it has to already be present in the DNA. If you strip it out, you can definitely make distinctions and differences in microevolutionary changes. But you can't make macroevolutionary changes because you don't have information in the DNA. And the more you select out, the less capable those species are of surviving if the environment around them changes. Okay, long hair, short hair, white moths, dark moths, doesn't matter. If you breed it out, then they're not going to be able to survive if the environment changes. What we see is that the designer of all things built in an original form incredible survivability, incredible variability into the original kinds from plants and animals and people right from the very beginning. So Jonathan Wells is a Christian, was I think maybe at this point, scientist, and he says biochemical mutations cannot explain large-scale changes in the organisms that we see in the history of life, which is, again, what we see. The observable evidence tells us we don't see large-scale changes. We only see micro changes, and those micro changes are easily explainable by the fact that the information to adapt that change is already present in the original life form. So the book talks about 5 reasons natural selection and genetic mutations fail as an explanation for what we see in the world today. Okay. Genetic limits, okay, according to their kind. Intelligent, again, covering what we just talked about really, but intelligent dog breeding always produces dogs. It never produces cats. It never produces horses. Never produces fleas. Okay. It only produces dogs. Okay. And that's what we see. That's the limit. That's the boundary with which you can use genetic manipulation of any kind. Now, okay, yeah, we can take a plum and a pear and genetically mix them and get some combination between the two, but we can't take a pear and a dog and get some kind of combination between those two things, right? They're too far apart genetically, and so we don't see that kind of. We can't take a dog and a cat and put them together and get something else. They're two different kinds. Now, we can take a donkey and a horse and get a mule, but they're of the same basic kind. Okay. Laboratory experiments with fruit flies, guess what? Always produce more fruit flies. They've never produced any new species. Why do they use fruit flies? Because their life cycle is like days, right? 3 or 4 days at most, I think is probably what it is. So they can go through what they might consider to be millions of years of evolutionary forces in a laboratory over the course of, let's say, 5 or 10 years. Because they just keep producing new and new and new and new generations of fruit flies over and over and over and over again. And what do they keep getting every single time? Fruit flies. What they would consider to be like the equivalent in a laboratory environment of millions of years worth of genetic material opportunities for change, and they only get fruit flies. And believe me, they've been trying to get something else, but they only get fruit flies. Mules, as I said, very close cousin, are sterile, and and this is often the case when we take two different, all part of the same kind, but we would call them different species. A lot of times they're sterile. You can produce them in a generation, but they themselves can't recreate according to their own species because they're sterile when they come to that point. That's not always true, but it oftentimes is true. So they have this table there in chapter 6. They talk about the differences between what you might say artificial selection, like intentional breeding, and natural selection, meaning unintentional, no guidance whatsoever in the process. So this seems helpful. Like if you want to breed a short hair dog, or you want to breed let's do something really weird. A hairless cat, okay? Yeah, you want to breed a hairless cat, okay? You're going to selectively breed until you get to the point where the cat you're looking for is hairless, okay? You have a purpose. You have an aim. You're saying, I will always keep breeding until I get to a hairless cat, okay? Were the original cats hairless? No. But you can selectively breed to that point. You can get a hairless dog or a hairless cat. That's your goal. Natural selection has no purpose, no aim, no guidance towards getting us to a hairless cat or a hairless dog, right? It's never going to do that, and it probably has no survivable, benefit to the organism to be hairless. More than likely, it's either going to sunburn to death or it's going to freeze to death or whatever. It's probably not a benefit to the organism. But if people want it, with human intelligence, We can artificially select for that trait. So there's a process. Well, we use intelligence to get there. There's no intelligence in natural selection. Choices, you have a preference, you have an aim, you have a goal, you have some kind of, you can see what you're looking for and select for it. There's no preference again, no choices being made by preference. Protection, you can protect. You can say, this cat is 30% shorter or less hair than this cat. I see that. I'm going to protect it because I want to keep advancing that particular trait. Again, no protection. Freaks. Well, you're preserving the freaks, hairless cats, right? In this case, you're saying, I'm looking for the freak. I want something new and novel to come out of this. But in natural selection, it's always going to be eliminated because it gains no benefit to the species. In interruptions, or interpretations, as many as needed, right? You can just keep going and going and going and going. You say, I'm going to keep going. But with natural selection, it's unguided, so it never knows when it found something beneficial, and so it just loses it even if something were to occur. And then survivability of a species. Preferential, yes, because you want it to survive, so you keep it and guard it and protect it. And again, natural selection offers none of these things, and so it offers no benefit that we can see, and certainly there's no observable evidence that these kind of changes have happened. So, you kind of jump to a conclusion here. If intelligent scientists cannot break genetic barriers, why would we expect unguided and purposeless natural selection to have superior capabilities? If we can't get a salamander to turn into a snake, with all of our technology and all of our information and knowledge on DNA, why would we expect that natural unguided selection would be able to make that jump on accident, with purposeless? And this doesn't even count all of the weaknesses that would go between. A lot of times we talk about like a snake to a bird, a reptile to a bird, right? Well, it's got to go through a whole bunch of changes. And most of those changes would not just not benefit the survivability of the species, it would be very detrimental. Can you imagine a snake crawling around with a bunch of extra feathers on it, but the feathers won't let it fly and escape away predators or fly to catch prey? It's just dragging around a bunch of feathers with it, going, I can't wait till I get to be a bird someday, right? It's got no additional survivability to it. And the hollow bones that birds have that snakes don't have. What good are hollow bones to an animal that needs to survive on the ground? None, right? Why would we expect these? And of course, Darwin, in his Origin of Species book, he talks about that. He says, if my theory were true, the fossil record ought to be filled with transitional forms. We ought to find way more fossil forms in transition than we find in actual completed forms. Because to get from a snake to a bird, there ought to be like 40 million different attempts that you can see the sort of changes happening, and then you get from a snake to a bird. So there ought to be just filled with it. And he then looks at it and says, but even back 150 years ago, or whenever our Darwin wrote, he said, but the lack of evidence is perhaps the most damaging fact against my own theory, right? There's no transitional forms. Well, in 150 years since Darwin, and we've got the world on fire looking for transitional forms, we still have zero to account for. Every single claim that they've had as a transitional form has later been proven, if not immediately proven, to just simply be a different animal we never knew about before. Fully complete, no transition one kind to another. Its own genetic structure. So, then they talk about cyclical change. Changes within a species, shifting as we talked about with finches or moths or whatever, shift back and forth within a very limited range. And it's always done to meet their environmental changes that aid their survival. So do we believe in the survival of the species? Yes. Or that the fittest survive and all of those kind of claims. Yeah, we believe in that. And as it gets warmer, it changes and certain traits will be preferential. Gets colder, certain things will change, and certain traits will be more preferential. But they never shift, make these big jumps from kind to kind. We do not see that. You can go to all natural history museums in the world, you won't find a transitional form. You might find claims on a placard somewhere that says it's a transitional form, but it's not actually a transitional form. It has you can't see the partial snake and the partial bird, the partial fish and the partial gecko, whatever it is. So we see again, changes never result in new forms or even permanent changes. The only time it's ever permanent is if it's lost so much of its genetic information, it can't go backwards anymore. Okay, that's the only time we see it, the permanency of the changes. But within a species or a kind, we see continued survivability built within the variability of the genetic code in the animal itself. Natural selection may aid in explaining the survival of the species, but genuinely it offers no evidence for the arrival of a species. These are really just plain facts. It should not be disputed, even though the Darwinists and the evolutionists and all of that hold on to this thought process with incredible vigor and tenacity, but there's really they can't explain the arrival of the species because, again, it's a digital code within the DNA, and it offers no insights on how you can change a digital code to jump from one species kind to another. Then we get to irreducible complexity. This term's been around now for probably 25 years or so. I think it was genuinely or originally coined by Michael Behe. There's a few quotes from him in here. Irreducible complexity, we'll walk through this and talk about a couple things. Okay. So in order for a genetic mutation using natural selection to be beneficial for the survival or the adaptability of a species, it must prove to be beneficial within a single generation. Okay, this is what I'm talking about with a snake with feathers and hollow bones and whatever else it's got going on. It has to aid survivability, or it will not, by the laws of natural selection, be preserved. And if it's not preserved, there's no way it's going to be passed on to successive generations. So because macroevolution, the big changes, hypothesizes that successive multi-part mutations have come together as a beneficial change, then all the mutations must happen simultaneously and within a single generation for a selection to occur that gives survival preference to a new species. Okay, so we can take the eyeball for a moment, if anything, the very first sight, right? So an amoeba didn't have sight, and then suddenly a trilobite or something had eyes, and you say, okay, well that certainly would have aided the survivability of species. Okay, let's just take our eye for example. Okay, when it's incredibly complex, but you suddenly have a lens, and you have an iris, and you have receptor cones, and you have all the millions or so of these optic nerves that go from the brain to the eyeball and all of that. I give you any of those, it won't aid the survivability of species until it's all hooked up and working and functioning properly. Beyond that, all you do is you got a mess. You got a little soft part that leads right to the brain, and any prey can come in and you can't see it, but it's going to kill you because it's got an easy access to your brain. All of those parts have to function at the same time. So in Darwin, even talked about the eye, the complexity of the eye, and thought, boy, that's a really hard one to resolve by my theory, because it's got so many parts to it. It's got so many different parts and pieces of it, and it's just connected, and it works, and how does it all happen? Darwin couldn't figure it out. There's been lots of, you can find all kinds of, atheistic, Darwinistic kind of thinking out there. We'll try to somehow explain the eye. They'll also try to explain, well, the eye really isn't the ideal design. If I were designing the eye, it would be so much better if I would have done it rather than, natural selection or God or whatever. But they actually showing a whole lot of ignorance, because the eye is incredibly, incredibly precise and complex. The fact that you can see clearly is a miracle all by itself. You got to have a liquid film right over the top of the eye. It's got to be right at the right viscosity. It's got to be right at the right level of clarity, and anything else, every person on the planet would just have blur vision. Really fine-tuned, the eye. And then it has to communicate to the brain to tell it something. So it's really in this area. So your irreducible complexity. An irreducibly complex system is comprised of several well-matched interacting parts that contribute to the basic function. wherein the removal of any one of the parts causes the system to effectively stop functioning. So it talks about like single cells are irreducibly complex. If you look at that, like I've talked about several times now, cell, way more complex than anything that human beings have ever built in their entire existence. Okay, way more complex. Not even close. The DNA is the most complex and most dense information storage and retrieval system on the planet. Way more storage capabilities in our DNA than any computer that's ever been built, and it can copy and replicate itself way faster than any computer could possibly generate that much of information. And that's just the DNA in the cell. All the other functions, all the other parts of the cell are also incredibly complex. Okay? And we also have that chicken and the egg thing that we talked about, where DNA makes protein, and DNA is made up of protein, so how do you get one without the other? Right. There's a Michael Behe's book talks about the flagellum motor in a cell, in a bacteria, and I included that link, or a link to some of that, in last week's notes. It looks like, really, they talk about it looks just like an outboard motor for a boat. Okay, it's got a motor and a rotor and a stator, and it's got a drive shaft, and it's got a propeller, and it's got all this kind of stuff. It's got like hundreds of different parts that would not move that amoeba through the water, like a microscopic level, unless it all functioned and all worked at the same time. It has to be built and functional, and not only that, it has to be built in a specific order. Like it needs a blueprint of how to build it. You have to build the shaft, you have to build this, you have to build that, and then it all comes together. Like I said, there's a video in last week's notes if you actually get that typed in, or just go to Google and type in flagellar motor, and it will bring up probably 50 or 60 different videos on it. Any one of them will show you whether it's from a Christian and a creationist, or a scientist that has no religious viewpoint other than their own religion of atheism. It will still show you that this flagellar motor is incredibly complex. Could not possibly work or function and successive changes over time. So visual systems are talked about, and then talk about cars and mousetraps. Like a car, just think about I'll talk about a mousetrap in a second, but think about a car. How good is a car if it has no wheels? Right? It can't go anywhere. It's got everything else. It's got lots of, $1 million car or a $100,000 car with no wheels doesn't get you very far. Just like a $100,000, Corvette or Mercedes-Benz or whatever won't get you anywhere if you don't have any gas, right? Or maybe we should say a $150,000 Tesla won't get you anywhere if you can't charge the thing, right? You can't, if it's not fully functional, it offers no benefit. Right? What are you going to do with a Tesla that you can't drive down the road? Sit in it and wish you could drive down the road? How does that aid the survivability of the species? So the simple one that what Michael Behe originally talks about is the mousetrap. It's one of the most simple contraptions you can find. And so we just walk through this for a second. So you got the base plate, you got a food catch, you've got a hammer that when the little critter tries to get the food, the hammer comes down and breaks its neck. And then you got the catch that comes over the top of the hammer to keep it from tripping until the actual mechanism is tripped, right? So you got 4 or 5 basic parts to this thing. And the question is, if you take one of those parts away, how many mice can you catch? That's called irreducible complexity. You can't catch any mice with with fewer moving parts than you got here. And you take the hammer away, well, it all works, but you don't kill the mice. You take the bait trap away, well, it doesn't catch the mice. It all has to work. You have to have it all functioning. It's super simple. I don't know how much they are these days. So you probably buy 50 of them for $10 or something, right? They're super cheap, and there's nothing complex about it. But it simply catches no mice if it doesn't have all its functional parts. And you equate that to let's say an amoeba trying to become a trilobite. It's got to get all of those functions up and operational and helping its survivability, or it's not going to be preserved through the natural selection process. It's just a bunch of garbage and weight it doesn't need. It will not survive any more than mousetrap with 3 parts will catch, one third less mice. No, it catches 0 mice, even if it has 1/3 less parts. All right, with that, that's the kind of the Michael Behe and irreducible complexity mind exercise we have for there. We'll take a break and come back and talk about the rest.